Hello, everyone, and a very good morning, good evening. Dear authors, session chairs, and invited guests, welcome to Technical Session 7D. Myself, Samruddhi Mughal, and I will be the moderator for this session. On behalf of Global Knowledge Research Foundation and GIA Scholastic, it is my great pleasure to welcome you to the 10th World Conference on Information Communication System, Software Security, and Sustainability, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was successfully held yesterday in London, UK, and the virtual event is being conducted through Zoom from 29 to 30 July 2026. I hope you all enjoy today's informative, insightful, and interactive practical session. In this session, we have six paper presentations. Each presenter will be allotted 12 minutes for the presentation, followed by 3 minutes for the question and answer session. I will give a gentle reminder when 10 minutes have elapsed to help you manage your time. I would also like to request all the participants to kindly stay connected with us until the closing remarks of the session. If you have any queries or require any assistance during the session, please feel free to write me in the chat box. Before we begin the presentation, I would like to introduce the distinguished session chair for this technical session. Firstly, we have Dr. Gurdal Etik. Dr. Gurdal Etik, an associate professor at United Arab Emirates University, UAE, with over 25 years of extensive professional research and teaching experience in AI and analytics. His core expertise encompasses business analytics, data science, supply chain management, and artificial intelligence. I would like to request Dr. Etik sir to share their views with us.
With us. Hi, can you see me and can you hear me?
Yes, sir.
Yes. All right. Dear participants, dear organizers, welcome to this session. It's my honor and pleasure to chair this session. And thanks to Dr. Mogali for also introducing us. So we have a series of very interesting papers forthcoming. And as you know, we have the time limits that are available 12 minutes and 3 minutes for Q&A for each presentation. And I will be also assisting with some questions. I'll also be asking some questions. And I'm looking forward to hearing what our colleagues have come up with as interesting research. And again, welcome. Thank you so much for being here today. Thank you.
Thank you so much, sir. We have another session chair. We have second session chair, Dr. Priya Pise ma'am. Dr. Priya Pise is currently the Director Alumni Relations at MIT World Peace University, Pune, India. She has total experience of 20 years, including industry and academic. She has published more than 25 research papers in various Scopus, WOS, HCL, UGC, care journals, and conference. Her research areas are big data analytics, cybersecurity, cloud computing, and data science. I would like to request ma'am to kindly share their views with our presenters.
Yeah, hello. Good evening, everyone. My name is Dr. Priya Pise. I'm going to chair the sessions for today for the conference on information communication system and software security sustainability. I personally keep a very keen interest in the changeover in the technology all across the globe. And I'm very much excited to listen to all of you today. I feel that the instructions from Ms. Samruddhi are very clear to each one of us. So let us make the most of it by sharing the ideas. So thank you and all the very best to you.
Thank you so much, ma'am. Now let us begin with our today's paper presentation. I would like to invite our first presenter. Uh, Presenter is Janset Schwarz. The paper title is A Hybrid Conversational AI Virtual Patent for Occupational Therapy Simulation in Virtual Reality. Janset, are you there?
Yes, hello. I would like to share my screen. And can you see it clearly?
Yes, yes.
Okay. So good afternoon. My name is Janset Shawash, and today I'm presenting on behalf of myself and my colleagues at the Metropolitan University of Applied Sciences in Finland, a paper called A Hybrid Conversational AI Virtual Patient for Occupational Therapy Simulation in VFR. The paper presents an AI-driven virtual patient for occupational therapy training, and it is a design and development paper. So most of my time today goes to actually one problem, and it is how to let a scripted clinical scenario coexist with an unscripted conversational AI. So just to begin by introducing what occupational therapy is, because not everyone here, of course, works with it. So occupational therapy helps people carry out activities of daily living. So the everyday self-care and home tasks that are essential for independent living, like washing, dressing, cooking, etc. The practice of the therapy is observational and relational. So the therapist watches how a client performs an activity, and then he or she informs the physical, cognitive, and environmental factors behind it. And they intervene to, for example, to support safe and dignified independence, to propose some solutions, tools to make it to make the everyday living acts easier for the clients. So three things matter for this talk and for occupational therapy. So first, in training, we watch the activity and we talk with the client throughout the activity, and we move around the client. So this is very important to be able to observe what the client is doing. And in the training of occupational therapy, these skills need to be repeated and situated in practice. However, this requires a lot of resources, and its placements in hospitals and in homes are limited, and it's hard to standardize. So in our application, we try to resolve these issues by using a digital tool. So also, there's another motivation for our application, which is ethical. Because to produce something useful and productive in virtual reality, which will be helpful to the educational process, we need to provide something which cannot be provided in reality. So in our application, we are looking at a showering assessment, where a client is having a shower in their own bathroom in their home. And of course, this involves questions of nudity, intimate personal care, ethics, legal issues, what have you. And this cannot be really implemented in the educational context, because you cannot, for example, bring an actor to act as that, or you cannot ask someone to role play that, because it has a lot of limits on that. And what happens is that when students don't have this experience and they go into the real world, they face real problems. And they have these problems with real vulnerable people, for example, the elderly or what have you. So virtual reality application stages this safely and repeatably. So students can rehearse and practice and discuss before they go into the real world. Of course, it's not 100% foolproof, but it is a very good and a big step towards having this discussion with their teacher in a safe environment. And in this paper, we make 4 contributions. The first one is a model of immersive real-time occupational therapy simulation. It has free speech, learner-chosen viewpoints, and one continuous space where the kind of therapy session is happening. Second, it has a hybrid control architecture. This is the technical core and most of kind of what the presentation revolves around. Third, it is a narration design pattern with its cost reported honestly as a finding. And fourth, we built this app in both Finnish and English languages, and we have some findings on that implementation. So this is what the app looks like. This is Aino, like this Finnish virtual lady. She is built in Unity, which is a kind of a 3D engine, a virtual reality engine, and runs standalone on Meta Quest 3. So the student enters a fully modeled Finnish apartment, which is very typical of here, and conducts a home visit. So from arrival through the showering scenes and assessment to leaving the place and saying goodbye. And then the conversation layer is actually a commercial software development kit called Conva AI, Convi. And it was chosen because like about a year ago, it was the best in the market, and it really made it easier for us to build this application. It provides speech-to-text, the LLM, and the text-to-speech functions. So the client exists as two character identities. One is Finnish and one is English, and you have to choose like the language at the start. We try to have it more flexible. However, that caused issues in implementation. And the environment is observation only, so there is no object manipulation, no physical contact, and that was asked for by the teachers because that's how they do their simulation pedagogy implementation. And actually, this was not the first app of its kind. So other apps exist in other kind of therapy implementations, which we summarize in our paper. And we differ from them on two axes. First of all, real-time conversation, not all of them have real-time of that, and also spatial agency, because most of the apps do not have this ability to move around the client or move around the space. So compared with the other conversational AI patients, we differ on three aspects. So we observe an occupation being performed rather than interviewing a patient. Our progression is governed by clinical script rather than open case database, so it's more structured. And we address intimate personal care, which none of the applications do. So for the pedagogical design, actually it's part of the simulation pedagogy structure where we have three phases, which is the pre-brief, where students learn what to do in the simulation. And then we have the simulation where the students observe what is happening. And then we have the debrief, which is the most important part of the pedagogical process, where students are able to discuss and reflect on what happened with their teachers and colleagues. So the app only provides the simulation part of this three-part process. So the educators or the teachers ask for the experience to be observation only with minimal gamification, so no badges or points or anything like that, because that's how it's done in reality. So there's no scoring and nothing like that. And if a student misses a point or a hazard, it is then a point to discuss in the debrief after the simulation. So, but the observation only created a problem because without objects to manipulate and with graphics being not 100% realistic, it's not always easy to see what the avatar is doing. So the answer to that was narration. So the avatar, Aino, speaks her actions and reactions aloud. So for example, she would say the floor feels slippery here, or like, for example, the water is too hot. So the hazard becomes observable through speech as well as through animation. However, I mean, this comes at a cost. So some testers felt that she is speaking too much. So it becomes too talkative. But then like the teachers themselves said that that's okay, and it is to be expected, and that a lot of the clients actually behave in that way. So she felt realistic to them. So it's still a thing that we need to explore in the evaluations, which will come in the next month. Now we can show the architecture. Here it's very simplified, and like a fuller diagram is in the paper. So the scenario is authored as 29 sections. Each section is a data entry visible in the Unity editor. It maps a narrative identifier to a state, an action, and a flow. Which condition ends this section and which section comes next. So it has the structure and sequence. Because the clinical flow is data, not code, educators and designers can reorder or edit it without programming. So one very important point for us is that the teachers should be able to edit the application later once they have it and not rely on programmers to do that for them. So it's more usable and easier to implement. However, the orchestrator runs one section at a time. So we have move, state, speech, wait. And every section declares how it finishes through an explicit completion type. So it can be wait for speech, wait for animation, wait for the character's action, wait for arrival, combination of these, or none. So those explicit contracts are the key idea. And they let the clinical sequence kind of coexist with dialogue of unpredictable length, which is what we get when we use a conversational AI avatar. So we had a problem like with implementing this structure. So because we have two models of time, one is the model of time in Unity, and the other is the model of time on the side with conversational AI. And they didn't always agree with each other. So in the authoring tool, meaning the Unity program, a section marked auto means that no player response is expected. But sometimes the student would speak at any moment, breaking that rule. So what would happen is that the section timeout starts running, the student speaks at the last second, then the AI is still processing, the timeout fires, and the narrative advances to the next section. Then the response arrives, and the client replies to context that no longer exists because we already moved to the next section. So it resulted in duplicated animation, double speech, or corrupted states and bugs. The underlying fault is simple to state. The authoring model and the runtime model disagree about whether a turn is in progress. Just a moment. So we resolved it in 3 layers. First, we put a re-entrancy guard and a section queue.
Sorry to interrupt. It's a gentle reminder that you have only 1 minute left to
continue. So we had a response in 3 layers. So we issued guards. So if a student speaks out of line or too late, it is then disregarded. And this was done through the re-entrancy guard, the utterance tagging, and turn-gated timeouts. And I mean, it's still a problem with the commercial SDK. And now we are putting effort to build our own conversational AI tool because it would resolve these problems. And so far, our evaluation has been formative, just to feed into the design and development. And we will be having a fuller evaluation with educators and students in the coming months because this application will be implemented in our university. So far, the findings are, for example, 4. We have 4 main findings. So believability. The testers said that it was quite believable, although it's not 100% realistic. The narration balance is a big thing for us to address. So when is she talking too much? When is she talking too little? So we have to resolve that. And then the free speech collided with the script, like this divergence between the unit script and the conversational AI script. And of course, we also had like other glitches which we resolved. So also our discussion findings were that narration density is a design variable and not a detail, and we need to plan for it and implement it wisely. Third-party dependence has a real cost. It's a latency, limited voice control, what have you. So we are trying to build our own platform to resolve this. And so context-aware AI is our next level because even the commercial AI does not, for example, distinguish between how far the students is from them. And that is very essential for good OT training. So to conclude, we are going to proceed with student evaluation very heavily. The AI, the in-house conversation AI pipeline, richer client behavior, so there is more option and randomization from Aina herself, and breadth and configurability according to the teacher's requests and demands. So thank you. This is a presentation of our paper, and I'm happy to take questions.
Thank you, ma'am. Do we have any question from session chairs?
I have. Misha, it's indeed a nice presentation. My question to you is, how are you going to measure the performance of the system that you have designed with the various model that you've already stated during the presentation?
Excuse me, how are we going to measure the performance of the system that we are going to design, or the one we already designed?
You decide what and how it is going to be.
Yeah, so we are still going to have this discussion with the teachers, because of course there are the measures which measure the technical performance, and we already have let's say some numbers of that, like the lagging, like we are still debugging a lot of it, and there's a lot of glitches. So although the concept and the development have went well, it's still very glitchy and buggy. And like our biggest problem now is the latency and the problematics with the conversational AI. However, what we still need to do is do some evaluations for the design development itself. So, for example, does the learning are the learning objectives fulfilled? So we still have to do a lot of evaluation even on these more qualitative kind of measures, have the teachers tested, because so far we had limited testing with the teachers, and they are very important for the whole process, because are they able to implement it? So far they have been able. However, we need to test with a bigger number of teachers, with a bigger number of students, to see if this is, as a teaching tool, is it suitable for the students. Of course, we're going to be using, let's say, the standard tests, like the SAS tests, or kind of technology acceptance tests and what have you. But there will be also very specific tests kind of related to lagging, to like problematics, to learning objectives, a lot of qualitative testing as well, talking to the students, understanding deeper their experience with the app.
Okay. Okay. Thank you. That is it.
Cool. Thank you.
So, you have any question?
Very good work. Congratulations. Looking
Thank
forward to the future work.
Thank you so much, sir. Thank you so much, ma'am. With that,
Thank you very much.
let's move towards our next presentation. Our next presenter is Rodrigo O. Jesus, and the paper title is Analysis of Functional Requirements for Water Quality Monitoring in the Amazon Rainforest, a Systematic Review. You may start your presentation.
Okay, can you hear me?
Yes, sir, you're audible.
Okay, let me take the screen. Moment. Um, present. Okay, so hi everyone. Good evening, good night. I am from Brazil, Manaus. Our paper is basically a systematic review from the analysis of functional requirements of the water in the Amazon rainforest. It was built in a partnership between Eldorado Research Institute and our University Federal from Amazonas. Uh, Let me just remove this. Okay, so why this problem matters? Basically, we have a lot of different challenges searching to when we need to deal with the quality control more than what we was expecting in the beginning. So we have environmental, social, and infrastructure from the beginning. A lot of surprises also searching these, like for example, the mercury contamination. We have a lot of illegal gold mining cases here in Brazil, especially in Amazonia. So it results in not only the the solid that increases, but also the mercury resulted of the gold mining, because they use mercury to separate the gold of the other things. The grant method also is not easy to scale. Basically, today, uh, a person goes there every 6 months, probably. I don't remember the period, but six or something like that, and manually collects the data, collects the water in specific points, and bring back to the laboratory analysis. And we also have the forest itself, because it's really hard to navigate here, to translate here, to to go to the path here. Last year we got the analysis that they observed 150 tons of the mercury in the water. It's really dangerous to the population. We have indigenous people here. We have people living closest to the water that they really don't have another option than drink that specific water. And they basically are drinking mercury and all the other stuff that the water have. So we still have cases today when they go to the indigenous, the people living there, they collect blood, collect all the exams, and they can see the mercury is there. So it's not healthy for them, it's not healthy for anyone. We also have the SDG6, that is the global um, global organization that's a value that tries to focus in the quality control. Uh, and we try to basically continuously build something that can especially avoid that human method that we have today. The objectives of this is basically uh, separate here the functional and non-functional requirements for the system that we need to put there in the Amazon rainforest. We need to focus in the sensors that we need to choose, because we have a lot of sensors for a lot of things, but we need to focus in the rainforest environment. And I need to explain to you that this paper, this initial paper, was thinking about the design foundation, not the device itself. So we only prepared a proof of concept, and that's the main idea here. What are the main questions that you want to answer here? The first one, what are the main physical parameters that we need to monitor? Which IoT platforms are most applied here? How can we deal with the connectivity? Uh, how is the collected data delivered to the applications? The data that we collect in the water? And the architectures that we need what are the architectures that we need to improve, to search, to develop, to support the rainforest environment? Our methodology started searching mainly for papers related with water quality, water monitoring, IoT, Internet of Things in a general way, because searching directly for the Amazon, for the rainforest, all the specific areas that we are started to search wasn't enough. So we need to first be really generalist in our search, and then after this we did another filter and focus more in the Amazon and the rainforest behavior. Also in stuffs like connectivity, network, and we finished the initial review, the initial filter with 33 articles to prepare as a base for our systematic review. It's really important to share that the rainforest behavior, the quality control is really common. You see a lot of papers as we saw, but the quality control inside the rainforest and specifically inside the Amazon rainforest is really scarce. We don't have it today. We also separate here the requirements that we need to have this device working it and this how the system is working, like the data acquisition, what sensors we may need to prepare it, the edge processing, because we don't want to send a lot of trash to between the data between the network. So we wanna filter, we wanna process everything directly on the where the sensors are and just send the relevant data. We need to focus on the environmental resilience, because we need to consider that we will put something there, it will receive rain, the all the types of the water, all the types of the withers, so it needs to resist all the environment issues. It needs to be easy to maintain and easy to scale, because it was one of the pain points that we had on the beginning. We need to focus on the connectivity, because we have the distance, the forest itself. We have a lot of problems to maintain the connectivity with the sensors and the applications. The data analytics, we need to find some better way to store, to visualize, and do something with the data that we are collecting. The power consumption, because since we will put something there, it's not so nice that we need to keep going there just to change the battery, to change anything related with the power consumption. So we need to focus in a lower power consumption design. And the sustainability. We don't want to put something there that will, on the beginning, helps in some perspective and will be dangerous for the environment in another perspective. So we wanna help without doing any bad behavior on the end of the process. And the design application here shared to us that the nothing here works alone. We really need to focus in the the best approach for each of those requirements. And the most important, what should be monitored? Because in the water we have a lot of things. As we saw, we basically on the regional experience here, we need to focus on the mercury based because of the gold mining. It's really important that we need to for the human health that we need to focus on that. We need to see the temperature because as more hot we have or more cold, it will impact the life in the ecosystem. The turbidity because it directly impacts stuff like the sunlight going to the plants, the river, and the visibility of the people that's needed to use the river for their lives, and the pH too because it really also impacts in the life ecosystem there. And it needs everything here needs to consider the chemical, the physical, the all the details in the environment that will be there. We also put there some models that we suggested to this approach. We searched a lot of types of sensors and separated specific models that may work better in our regional environments. About the connectivity and the edge processing, we consider a mix of a lot of technologies. Like for easy dashboards, we really consider to use the regular Wi-Fi or the mobile data. It will be better to communicate with dashboards, cloud, and be able to access in mobile data, mobile phones. For large distance, we consider the TV antenna that will basically access all the bandwidth that we already know that works well for our TV, so may helps us in our type of data connectivity. And we also try to combine the heterogeneous networks like SORA, LoRa, Sun as a gateway to increase the bandwidth and allow us to really do not worry about the all the forest that we have around our sensors, our system. From the data to what's really important, what will be really significant here. Uh, we try to collect the data in specific sensors and do all the filters, the initial filters there. We want to send to machine learning models for water quality control that they are trained for water quality control, turbidity, uh, solidity, and prepare all the initial analysis. And
Sorry
then
to
with this,
interrupt. Sorry to interrupt. It's a gentle reminder that you have 1 minute to conclude your meeting.
okay, thanks. And then use the data for a significant thing, like we think at on beginning on alerts, visualization, and provide this for the public, for the government, and they can do the next actions. They have the power for that, but not only collect the data and use it for a study purpose. We wanna use that for something really relevant. The architecture that we designed here is basically the sensors, the edge layer closest to the sensor to filter the initial data, the gateway to send the data to the cloud to save our data, and the applications to handle with all the relevant actions that we designed and we decided to have here. About the conclusion, we we basically consolidate all the function and non-function that we things that we need for our specific condition in the water quality control in the rainforest. We discover a lot of mix of heterogeneous network and connectivity to handle with our environment, and we mapped the sensors in a lot of shopping of sensors to that may work in our specific condition. Our next step is to really build something to remove these from the paper and go into the field and starting develop something really useful in the real world. And that's it. Thanks for being here, and we are open for any questions.
Thank you, sir. Do we have any question from session chairs?
Yeah. Hi. My question to you is, I mean, although the topic is really very interesting, so I have a question for you. Like, how did you use select the sampling location for the data acquisition? Because,
Mhm.
everyone knows what Amazon River is. So you can answer this.
Yeah, yeah. The basically we try to search specific locations that are basically in strategy positions, like closest to possibly gold illegal mining places, or closest to where places where people live, not just random places, but strategic places that will impact in the life of someone, at least.
Okay. And have you used any satellite data, my dear?
Not yet. They they included. I probably didn't mention. They included the satellite technology to use in the final device. But for this part, this initial analysis, we didn't use the satellite.
Okay. The very best. Thank you.
All right, I have some questions as well. First of all, I wish you the best in this huge initiative. It's a very big challenge. What is the size of the Amazon? How many kilometers squares?
Oh,
Millions,
I don't have
right?
no, I don't have the exact number here, but it's
Millions. It should be
really really
millions, if not billions. Yeah.
millions.
So
Yes.
while I was listening to, I also took the abstract of the paper, which is already online, and I just
Mhm.
asked ChatGPT, are there any benchmark studies where large forest areas have been monitored in other parts of the world? So, do you have any benchmark studies that is basically that maybe other people already did this architecture before you and they already
Mhm.
implemented in another part of the world? Have you had a chance to do this search beforehand?
Yes, we searched it and we saw a lot, especially uh, on Indian rivers, we saw a lot of research there. But we didn't search it things focused on the forest method. The sensors may work well, the sensors from the all the places that ChatGPT recommended to you and the papers that we found. But the connectivity was probably the hardest part in our research here because of the forest method. And the mercury, we still have papers and cases using and controlling the mercury as well, but not as we need. And it also focused us to develop this.
Mhm. Yeah, for example, here I'm seeing there's a study from Finland. It's called Soil Weather, and they had sensor nodes covering 2,000 kilometer squares. Then there's another
Mhm.
study from China, then another one from United States. So I don't know. I mean, you did not mention these in your presentation, so it could also be nice to mention some benchmark studies, and also it could also be maybe good for you to
Mhm.
start with their methodologies. I mean, to
I
start
see.
with their architectures, sorry, to start with their architecture, system architecture, and then build upon that. So that's just a feedback for your
Uh,
research.
I
All
see.
right.
I see.
All
Okay.
right. Thank you. Have a nice day.
Mhm. You too.
Thank you so much, sir. Thank you so much, ma'am. With that, we'll move towards our next presentations. Our next presenter is Laura Alma Diaz Torres, and the paper title is Analysis of Operational Demand Using Telemetry to Define Catchment Areas Along a Public Transport Corridor in Mexico City. You may start your presentation.
Okay, I think you see it there. Okay, so hello to everyone. My name is Laura, and I'm presenting this with all of my team. The title of my paper is Analysis of Operational Demand Using Telemetry to Define Catchment Areas Along Public Transport Corridor in Mexico City. And we choose this topic because we are a company of many little companies of transportation in Mexico City, of public transportation. And we found that, okay, public transportation represents a really big challenge right now in Mexico City, and not only Mexico City, but in Mexico. And it's not only a service. It should be comprehended and took as a right. We have the right to be able to move. So being able to move makes us have access to services, to goods, to new opportunities, to schools, to hospitals, and all of that. So what we found? Okay, we found the first problem. We have different types of demand services that we can ask, how can I plan my service? How can I do this? And how can I plan my corridor? But it happens that with one of the companies that we can see, we had the demand analysis done before the pandemic started, and then the company started to run after the pandemic. So obviously it happened like we had like 4 years of not having public transportation or good public transportation in that zone. So obviously the demand changed. People decided that, okay, maybe I don't need to go to work because I could do home office. Or some people that went only to, I don't know, elementary school, graduated and went to university. So obviously it changed, that it's a dynamic urban context. So demand studies can change, can vary, and the accuracy of those is just one thing that we are having a problem right now with. So the central issue is, okay, the demand observed and the estimated one is not the same. So how can we do a methodology that can see all the demand that is needed, and how can we plan our routes, our fleet, our operators, our drivers, to make it efficient for all the public that needs that transportation. We had with this company in specific new buses and new technology. So what we did is that we took all the telemetry, and this gives us the entries and exits of the bus, and when the door opens and it closes. Also, that has all the geographic coordinates and the timestamps. So we could see when and where did people got on the bus and when did they get off. So with all of that, we also did a catalog of the official stops for the bus and the directions. And we chose to do two methodologies. One with the bus stops, because we do not plan the corridor, like the company does not plan the corridor, but the government does. So first, we needed to show the government, okay, so this route, people use it exactly as we planned it. So we took all the data, we put it in a bolt tree, and we decided to choose like the best or the nearest official stop. And with that, we decided to then make like the route reconstruction using direct graphs. After that, we check like, okay, maybe I did it wrong or I did it right, like because some routes have like one stop in one part of the same area of catchment. and it's to go to the north, and the other one is to go to the south. So we decided to give it like a score. With that score, we decided, okay, there's some routes that have so low score, like the lowest score ever. We had like a 54 or so in some routes. So we started to study why it happened, and we saw that they changed the route. Like the bus does not always respect the route. And why it happens? Well, in that zone, in that specific zone in Mexico City, there are a lot of flea markets, there are a lot of parties, and the parties here take all the street. So we decided to change how we saw it. So we decided to use heat maps. And we saw that, yeah, there are some routes in a specific that on Wednesdays do not take the specific route that is assigned by government because there's a flea market. And that changes everything for us, because if we know that we have a flea market, why put the bus stop in the middle of the flea market, right? So we use heat maps, and we like follow the same as the other methodology. That is like, okay, we make polygons to see where the catchment area is. And then after that, we see which bus stop is in that polygon, and we can assign a route. And by that, we can see if they follow the route as planned, or we can change how it went, right? But we have some like good things and bad things about both methodologies, because okay, we have heat maps and we can see where actual people goes on the bus, hops on the bus, and where does they go off. But the government wants us to follow the route. So we had like advantages and disadvantages, and also limitations. So for the first method, it's beautiful that we can consider each stop and like a sequence, but we lose the real movement of the people that the second method does have. Some limitations of the both methods is that in the first one, well, we try to rely on those official bus stops. The second one has some bus stops in the same polygon, so sometimes it gets mixed up, and it's a lot of noise in our data. So each method has its own advantages, some limitations, and the disadvantages is that sometimes we lose traceability with the second method because we cannot always follow, like the same bus follows the same route on Wednesdays because the flea market, because sometimes they get a bigger market, or sometimes they have the flea market and a party or something like that, and it changes, right? The other one is we want it so normal that we can hide some deviations and informal stops that we have and that we need to see. So our proposal was a multi-criteria integration. We take both systems and we put it in a multi-criteria decision layer, so we can put like more robust demand zones. This gives us operational traceability, real spatial behavior, and we can have like the candidate criteria. Like, where are the distance of the official stops? Where is the boarding, the hour frequency, the route alignment, the direction of each travel, the polygon overlap, and all of this gives us to how we can classify demand by points and how reliable is how we are doing our decision making. This is important because here in Mexico, we need to improve our transportation methods. We need to make like we need this algorithm so that we can take timetables and frequency, and we can improve the service. The vehicle allocation, we purchased more vehicles that we needed because of course the demand changed, and actually it was less than expected. So we can have like better service if we can see where do I need to put my buses. We can also see a priority service area. After this study was done, we decided that we need a new route, like an express route, because sometimes like at half of the complete route, we lose all of our demands. So the bus can take a return, and go to the other side and continue to make a service, and we can reduce the frequency between buses, right? And of course, operational validation. Now, for our future work, we
Sorry to
want
interrupt.
to,
Sorry
yeah,
to
don't
interrupt.
worry.
It's a gentle reminder that you have only 1 minute to conclude your
Sure, don't worry. For our future work, that's the last thing that I'm going to mention, is that we want to be able to plan according to the calendar, because we have in Mexico sometimes routes that just work for a school, like when school is working, and when there are vacation, we lose all of our demand. So for our future work, we are going to do the same thing, but including the calendar, so we can estimate our demand properly. And we can see if it's not all only the schools and everything like that. We also have hospitals, we have services like gyms and sports allocations that also need like a good transportation service, but we can do it better if we can plan accordingly, and we can do the demand analysis with real information and in less time than 3 or 4 years. So that's everything. Thank you so much for your attention.
Thank you so much. Do we have any question from session chairs?
Yeah, Miss Laura. Have you used transport network graph?
Yes, but this study only focuses on the buses that are on the street.
Okay. So I am I want to know, how did you make it? Can you explain a little? Transport network graph for the city Mexico.
Yeah, okay. The transportation here in Mexico, we have a lot of systems. We have bus rapid transit, it has like a one lane where it can go freely and no one else can go. We have this type of buses that is just one corridor. There are the buses that go on the street with the cars and everyone on the same lane. And we also have underground. We have the new one is cablebus, that it's telepheric transportation mode. We have all of that, but in this study and demand studies sometimes focus more on buses that go with all the traffic, and that's why we wanted to focus on that, because we cannot always control all the different systems that are working together in one area, like the traffic, or like, for example, when I don't have a school working, obviously parents don't go and drive by the school. So I have less traffic, but I also have less people that want to go on a bus and take that road. So we use 3 methods to do this work, with both three. Network X to do like the graphs of following each route, like going one side to the other one. And we use polygons, and with the polygons we also use Network X so that we could check like the sequence of the polygons and how they went.
Okay. So it becomes a weighted graph, or what?
Sorry, I didn't understand.
Is it a weighted graph? Is there any weight assigned with respect to all the nodes? Weight can be the cost, or the redundancy, or whatever you assign it.
We do have one road that we are supposed to follow by the government, and how it's supposed to work by
That's
government.
fine. That's fine. By default, it's a weighted graph. Okay. Okay, that is fine, Laura. Best wishes to you.
Thank you. Sorry, I don't.
Third, do you have any questions for Laura?
It's okay. Thank you so much.
Thank you so much, ma'am. Thank you so much, sir. With that, we'll move to our next presentation. Our next presenter is Sai Patil, and the paper title is Beyond Single Dataset Evaluation, Feature Space Mismatch and Cross Dataset Adversarial Transferability in Network Intrusion Detection System. You may start your presentation.
Hello.
Yes, you're audible. You can start your
Okay.
presentation.
So, hello everyone. I'm Sai Patel and I'm presenting our work Beyond Single Dataset Evaluation, Feature Space Mismatch and Cross Dataset Adversarial Transferability in Network Intrusion Detection Systems, conducted with my co-authors Vaidehi Pathak and Purva Nalawade, under the guidance of our professors Dr. Rupali Vairagade and our HOD, Dr. Nilakshi Jain. This work basically looks at how well adversarial attacks against intrusion detection systems hold up when they are moved from one dataset to a completely different one. Nowadays, intrusion detection systems basically rely a lot on machine learning and their accuracy often exceeds 98%. But these models still remain vulnerable to adversarial examples, which are small, deliberately crafted changes to malicious traffic that can cause an attack to be classified as benign. And now, for this, the real question is not just uh, whether one model can be tricked this way, but it also whether the same trick, which is built for one system, can it also deceive a completely different trained system. And this property is called as transferability. This is the central problem our research looks into. This is not just a hypothetical scenario, uh, and this scenario does play out a lot in real deployments regularly. A company's intrusion detection system is often trained on its own private network traffic, and outside attackers don't have access to this data. So, what attackers do have access to are public benchmark datasets like the ones we have used in our study. So, realistically, the threat model is that an attacker can train the adversarial attack on publicly available datasets and hope that it generalizes to the private target systems also. And if it does generalize, then the target can be evaded without the attacker actually ever touching the real training data. And this is different and a more dangerous scenario than what prior research has ever tested. This research is grounded in prior adversarial machine learning research, like the one conducted in 2014 by Segedi, which documented that adversarial examples to transfer between independently trained models. And in 2016, paper no showed transferability could be exploited for black box attacks using surrogate models. Uh, but for NIDS specifically, the work by Han et al. Demonstrated evasion rates which were above 97%. And recently in 2025, the work by Zhang et al. Extended this adversarial evasion to cross-model attacks on NIDS. But the gap is that none of them tested the case where the attacker's dataset and the defender's datasets are different from one another, and this is the scenario that happens in real life with real life attackers, and this is the gap that our study addresses. So, countering this problem first starts with measuring it correctly because most studies do measure the risk, but not under real world deployment conditions. And a proper way to approach this would be first testing everything independently. Uh, so testing across independently trained models and mainly independently sourced data sets and not just different splits of the same data. It also requires a structured, complete comparison rather than just a handful of isolated examples so that we can actually see the genuine patterns emerging. And finally, it also requires explaining why an attack transfers, and if it does fail to transfer, then why, via geometric and statistical analysis rather than just reporting the success rate in isolation. This is the foundational step so that a real defense can be designed. Uh, it can be designed only when an actual threat has been correctly measured. For our implementation, we used two of the most widely known NIDS benchmark datasets, that is CIDS 2017 and UNSW NB15. These are constructed using very different tools and they exhibit different traffic characteristics. And CICITS has about 504,000 test samples across 52 raw features, and it is heavily imbalanced at 83% of benign traffic, while UNSW has about 51,000 test samples and across 36 raw features and is more balanced at roughly 64% attack traffic. But because their features don't align directly, we decided to apply feature harmonization, and this involves selecting 10 features that represent the same underlying properties in both the data sets. For example, we selected flow duration, packet count, byte counts, and window size. And for every experiment, so on, we use these 10 shared features. For the models, we use two main models, Random Forest and XGBoost, and we trained them separately on each of the two data sets as discussed previously. And in total, we got four trained models. And for the attack, we use boundary attack, which is basically a black box decision-based method where the attacker can only observe the label that has been predicted. So they can only see whether whether the attack has been classified as attack or benign, and they don't have access to the model's internals or gradients. And this reflects a more realistic scenario of the attacker's interaction with the deployed system. And it also works on tree-based models like ours, which don't support gradient-based attacks. So for every source model, source model's attacks, we tested every target model, and every row was tested against every column, which gave us this 4x4 comparison matrix and gave us 16 attack success rate measurements. So as shown in the matrix, each row represented where the attack was built, and each column represented what it was tested against. The diagonal basically showed a white box case where the attack was tested against its own source model, and everything that was off the diagonal was a genuine transfer case that involved either a different model or a different data set or both. So from this study, two main patterns emerged. First was that when models changed, but the data set stayed the same, the attack still worked almost perfectly between 89 and 100% success. So, which means that changing only the model architecture does not protect a system if the training data is the same. But we moved, but when we moved to a completely different data set, the success rate dropped significantly to somewhere between 5 to 44%. But this does not disappear completely, and that remaining risk is what we examined. Within this 5 to 44% range, uh, we found an exploitable pattern, and when an attack is built using the UNSW dataset and tested against a CICIDS trained system, the success rate stays in the 89 to 100% range, which is nearly as strong as within dataset transfer. But when we go to the other direction, that is from CICIDS to UNSW, the success rate drops to a much weaker range of 5 to 44%. This means that an attack could be built, this means that the attacker can build an evasion using a free publicly available data set, and the attacker would never have to touch the target company's private data, and they would succeed in an attack against a production style system most of the time. The underlying reason for this is because the traffic pattern sits in two different regions of the feature space, and to confirm this, we used PCA projection and KL divergence analysis. So that showed that only 6 of our 10 harmonized features have very low distribution overlap between the two data sets. But attacks built for one data set generally don't travel enough to reach the other's decision boundary, except in this one direction where the gap happens to be crossable. So the three main practical implications from our study is that first, different model architectures alone don't carry robustness, and training diversity matters just as much because since within dataset transfer stays above 89% regardless of the architecture. Second is cross dataset transfer uh, is real is real, but the transfer never is it is not negligible, but it is clearly reduced when there is genuine difference in the distribution between data sets. And uh, most importantly is the directional asymmetry that we found as a genuine security risk. A public dataset can serve as a surrogate attack platform against a real world system. And the in simple words, if a network intrusion detection system is getting evaluated for robustness and you use only one data set, the evaluation will capture like an incomplete picture of the real world adversarial scenario. So, we would like to take our study in two main directions. First is we wish to widen the scope of our study as we have only used two data sets, that is CICRDS and UNSW, and we wish to use more data sets. Second would be extending this analysis to deeper learning architectures such as CNNs and LSTMs rather than just tree ensembles. And we would also like to confirm whether these patterns do hold when we use against other black box attacks, and whether this pattern is not just for boundary attacks. The second direction is building actual defenses based on these findings, and this process involves training detection systems on data from multiple sources at once so that there won't be any single blind spot that can be easily exploited by attackers. We also wish to extend the adversarial training across distributions rather than just within one. And we wish to use ensemble to build more independently trained models as an additional layer of protection. Thank you.
Thank you. Um, do we have any question from session chairs?
No questions from me.
No question from me too. Thank you.
Okay, ma'am. Thank you. Um, with that, let's move towards our next presenter. Our next presenter is Yezel Clavel Quintero, and the paper title is Building a TripAdvisor Dataset for Irony-Aware Sentiment Analysis. You may start your presentation.
Hello everyone. I'm sharing my screen.
Yes, you are audible.
Well, my name is Giselle Clavel Quintero. I'm from the University of Holguín in Cuba. I'm going to present the research building a TripAdvisor dataset for irony-aware sentiment analysis. The internet significantly transformed the business landscape, particularly the tourism industry, by removing geographical constraints and time restriction, while enhancing accessibility for consumers. The digital traveler has become a common term. They are travelers who research destination online, digitally, and share review after trips. That is a standard practice today. User-generated contents are important to government, companies, and any organization because it helps them to analyze customer sentiment and evaluate service and product quality. The problem in this user review is that it's a common place for irony and sarcasm, and it can drastically change the meaning and polarity of the review, leading to mistaken analysis. Irony means implying the opposite of what is said, and sarcasm is a special case of irony that adds some mockery. Human reasoning detects the text is through contents, but in case automating system, it is well because in text, verbal and non-verbal communication is not taken into consideration. Also, there are informal language, abbreviation, and typos that add some noise. The content is based on cultural and linguistics, which complicates the analysis. So we identify the research gap that a few trial-versus data sets are labeled for irony, and to the author's knowledge, none were available with both irony and polarity labels. The polarity classification state of the art is leading by support vector machine, KNN, and lexicon-based methods, classical machine learning algorithms. Deep learning outperforms them on cross-domain tasks. Techniques like by LSTM with attention and with stacked embeddings outperform traditional approaches. The key results in these tasks is the joint multi-grain topic sentiment with F1 measure of 84% on TripAdvisor hotel reviews. Irony classification, the state of the art is led by the tourist sentiment index framework, which achieved 95% on TripAdvisor dataset with LLM-based augmentation mass transfer learning techniques. Also, they apply feature selection with 7 features and attentive regular neighbors on tutor datasets. Most approaches use tutor or Amazon datasets, and most models are typical classical machine learning algorithms. We identify as a research objective, we let tourist domain dataset that capture both sentiments and irony. We use the TripAdvisor review because it's considered the site most visited as a reference for many customers. Then we apply transfer learning for detect irony and annotate irony and polarity labels in the TripAdvisor reviews, and then evaluate these reviews comparing the classical machine learning models identified in the state-of-the-art research. As the experimental design, we identify 3 main dataset: Sarkans V2, the Amazon dataset, and the TripAdvisor dataset. First, we train irony models on the Sarkans and Amazon datasets that are labels for sarcasm and irony, respectively. Then select the best model, then annotate the TripAdvisor dataset and classify the polarity. The models evaluated are KNN, super vector machine, random forest, naive Bayes, logistic regression, simple deep neural network, and LSTM model. Also, we use Gore embedding vector, a glove with 6 billion of words and 100 dimensions. The TripAdvisor dataset annotation, the initial polarity distribution was classified using the lexicon-based sentiment analysis tool Vader. Then we trained the MLM, the machine learning models to identify irony. In the case of coinciding irony labels in both cases, this classification is maintained. We can observe that the final irony labels are lower than the other previously identified as possible irony and ML irony. So, as a result, Logistic regression was the stronger classical model on the Amazon source dataset. This achieved better results than the other sarcasm dataset. In this research, we don't we treat sarcasm and irony as the same because the linguistic similarities and because we don't find some other resource available. So we achieve better results with the Amazon dataset with an F1 of 74%. Then this model, the logistic regression, was used to annotate the TripAdvisor corpus. We obtained the new irony-aware TripAdvisor resource with new final irony labels, and then we update the final polarity distribution. And for these tags, also the regression obtained best result with a fun measure of 89%. We can observe that the positive labels, the positive reviews, are lower than the initial classification, and the negative reviews are bigger, as an increase compared to the initial distribution. So taking into account the irony, it affects the polarity distribution based on the polarity classification previously realized. The resulting dataset is publicly available on GitHub. We share our URL for your review. This matter because more realistic for better sentiment analysis begins with better labels, and our result enable more realistic tourist intelligence, taking into account the effect of irony. We provide a domain-specific benchmark based on TripAdvisor review, specific for tourist sector. The dataset is a foundation for future experiments in sentiment and irony, in both sentiment and irony classification and in joint classification. This helps to identify better what the reviewer actually means. We conclude that this work contributes to the advisory dataset annotated for both irony and polarity, and our resource publicly available enabling future research in context-aware touring sentiments analysis. The logistic regression outperformed on Amazon data, achieving an F1 of 74% for irony detection and F1 of 89% for polarity classification. Deep learning the learning techniques underperform due to data requirements. So for future work, it could be valuable to evaluate the fine-tuning of small language models, apply dataset balancing strategies, and explore some alternative strategies for better parameter optimization. So that's all. Thank you for your attention.
Thank you so much, ma'am. Do we have any question from session chairs?
Yeah, yes, I have a question. Which algorithm is most sensitive to the noisy data out of which you have chosen?
Sorry, can you repeat, please?
I will repeat it. Which of the selected algorithm is most sensitive to the noisy data which contains some impurities?
Yeah. Well, in this case, the deep learning techniques outperform worse because the data are have some noise, and some data sets are small compared to these techniques that are more complex. So that's why the classical machine learning models achieve better results.
Okay. And what impact it has on the ultimate results?
Sorry, can you repeat, please?
Yeah. What is the impact of that impure data on the ultimate results?
The impact of the data?
impure data set that you're going to input?
Well, we don't find any other data set labeled for both irony and polarity. That's why we use the transfer learning techniques to annotate data sets for both tasks.
Okay. Okay. Any challenge in the
Thank you.
annotation that you have faced?
Well, mostly the hardware limitations. That's why we use small models.
Okay. Okay. Best wishes. Thank you so much.
Dr. Clavel Quintero, congratulations. You have done an amazing work. It's really impressive.
Thank you very much.
I have been doing text mining for maybe 15 years now, maybe more. And I've always run into this problem, like, there's some comments or there's some text, but actually what the text wants to say is different, actually, even the opposite of what it's actually literally writing there. And this is a very big problem. And, almost all the text mining research, text analytics research is based on basically word count, right? TF-IDF, and you just create the word frequency matrix. And yours is a very, very nice approach. Have you seen any other research that has taken a look at this? Because I saw that you have a data set on the internet. So is there any academic work done on any other academic work done on irony? Taking irony or taking sarcasm into consideration in text mining?
Yes, I'm researching for my PhD studies in mainly irony classification. That's why we apply this research, but we are researching in irony classification joined with other tags.
Okay. All right. So, and how did you get the original labels? Like, for example, in both the training and the testing data sets, the labels were already there in the source data sets that you got, or did you manually do those labels, or did you use some type of AI to create those labels of, whether there's sarcasm or not?
We train a model in a data set annotated for irony, and then this model was used to annotate the TripAdvisor data sets. And then
Right.
we did some manual reviews.
So the
some
original
percent,
training,
not the whole.
the original training data set, did it already have labels in it from the literature, or did you? It had it. Okay.
Yeah.
So
It's
that first
they are
data
public
set.
data sets.
Sarcasm V2 dataset. Okay, thank you so much. Congratulations again. Wish you all the best in your studies, Doctor.
Thank you so much.
Thank Ma'am. Thank you so much, sir. With that, let's move towards our next presentation. Our next presenter is Wilma G. Villasis. Paper title is Design and Validation of AI-level dialogue scripts for Immersive Virtual Environment in EFI Learning. You may start your presentation.
Good afternoon. Can you see my presentation?
Yes, it's visible.
All right, thank you. Well, good afternoon, dear colleagues. It is a pleasure for me to be here. My name is Wilma Villasis, and on behalf of my co-authors from Universidad Técnica de Ambato, Ecuador, I am pleased to present our research entitled Design and Validation of A1 Level Dialogue Scripts for Immersive Virtual Reality Environments in EFL Learning. Every single research study has a clear rationale behind, and ours is no exception. Virtual reality has been receiving increasing attention in language education over the past few years because it offers learners opportunities to communicate in authentic situations. Unlike traditional classroom settings, virtual environments allow students to interact in meaningful and contextualized ways, making learning more engaging and realistic. However, the review of systematic studies highlighted a challenge. Technological development has progressed much faster than the pedagogical frameworks that support immersive language learning. In other words, virtual reality platforms continue to evolve, and meanwhile, pedagogical frameworks have not been developed in order to ensure the quality of language acquisition. When revising the literature, we have identified a clear research gap. Most previous studies mainly evaluate the effectiveness of virtual reality. However, little attention has been paid to the pedagogical design of the dialogue scripts that support learner interaction. This omission is really important for A1 learners because these beginner learners require carefully designed Common European Framework aligned dialogue scripts. For that reason, our study responds to this need by integrating the Common European Framework descriptors, communicative functions, and useful language into a transparent dialogue design framework. Our research study has two main objectives. The first one is to develop dialogue scripts that align with the Common European Framework descriptors. And our second objective is to validate the dialogue scripts through a two-round Delphi process. Together, these objectives help us to ensure the quality of the dialogue scripts and also to meet the pedagogical quality as well as the level of beginner learners. To accomplish these objectives, we have adopted a material design and validation approach that combines the qualitative and quantitative component. The qualitative component consisted of collecting detailed feedback from experts, and in the quantitative component, we analyze the Delphi ratings that we got from a structured questionnaire with a Likert scale. The dialogue scripts were designed for university students, and in the validation process, we had the participation of 5 experts in applied linguistics and EFL language teaching. The panel of experts held, 4 of them held doctoral degrees and 1 a master's degree. All of the experts had extensive experience in EFL instruction, in curriculum development, and Common European Framework-based language assessment. The dialogue scripts were evaluated according to 4 dimensions. The first one, alignment with Common European Framework A1 communicative functions. The second, linguistic simplicity and accuracy. The third, naturalness and authenticity. And the fourth, interactional effectiveness. The dialogue scripts were designed following this methodological framework. The process consisted of 4 stages. In the first one, we analyzed A1 Common European Framework descriptors to identify specific spoken interaction and communicative activities that were according to the target level. In the second stage, we selected 2 high-frequency Common European Framework settings for simulation, a university campus environment, and a shopping center. In our third stage, we identify essential communicative functions that align to the Common European Framework for every single scenario, for example, greeting, asking for information, giving directions, among others. And in our final stage, we identify the A1 level linguistic content based on 3 criteria: frequency of use, communicative relevance, and pedagogical suitability for beginners. After the dialogue scripts were developed, they were submitted for as the first Delphi round for expert evaluation. When we got the results from the experts, they mentioned that our dialogue scripts were educationally valuable, but there were some observations that helped us to improve. For example, in the linguistic level alignment, experts mentioned that there were some grammatical structures and some sentence constructions that were too complex for the level. They also mentioned that some vocabulary items were unfamiliar or difficult for beginners. Concerning naturalness, experts noted that some expressions sounded formal or unnatural. And regarding interaction and effectiveness, experts suggested including more phrases commonly found in real conversations. These observations were really important because they help us to refine the dialogue scripts, and we took some actions. For example, grammatical structures were simplified, the lexical difficulty was taken into consideration, dialect terms were shortened, conversational naturalness was improved, and interactive strategies of authentic communication were incorporated. So as you can see on the next slide, we have some samples of the final dialogue scripts. In the first one, we can see a conversation between two university students in the classroom. In this conversation, they are asking for information, they are talking about hobbies, they are talking about work, and they are also making arrangements to meet. In the second conversation, we can appreciate a conversation between a shop assistant and a customer having a conversation about buying clothes. This is the evidence that we can integrate common European framework descriptors, we can integrate communicative functions as well as useful language in order to design valuable material for students. So once the dialogue scripts were refined, they were submitted for a second Delphi round. So after we received the results from the second Delphi round, we could compare the results. And as we can see here, there is great improvement. There is significant improvement.
Sorry to interrupt.
Yeah.
It's a gentle reminder that you have 1 minute left to conclude the
All right, thank you.
presentation.
So I was telling you that the results help us to notice that there was a great improvement in the quality of the dialogue scripts. The overall mean increased from 4.28 on the first Delphi round to 4.56 on the second Delphi round, indicating that there was a great improvement in the quality of the dialogue scripts. Our study has a contribution. It gives a systematic, adaptable framework for designing common European framework dialogue scripts for immersive virtual environments that can be replicated and adapted to different educational contexts. However, it is imperative to mention that technology alone cannot guarantee meaningful language learning. It must be supported by the pedagogical support. To conclude, our study demonstrates the dialogue scripts for immersive virtual environments can be systematically designed and validated through a structured pedagogical process. In fact, the dialogue scripts were considered appropriate for A1 learners and aligned with the communicative objectives established by the Common European Framework. Finally, this study provides a transferable framework that integrates Common European Framework descriptors, communicative functions, useful language, expert validation into coherent methodologically for developing immersive language learning materials. Although the study was limited to a small panel of experts and lacked classroom implementation, this led to our future research. Our future research will focus on immersive virtual reality implementation, incorporating learner feedback, examining the impact on the speaking development. So thank you for your attention, and we sincerely appreciate your interest on the research. I'd be happy to answer any questions.
Thank you, ma'am. Do we have
Miss
any
Vilma. Yeah, Miss Vilma, it was indeed a super presentation, and it was a self-explanatory one. So I have no question for you. Thank you.
Thank you.
Sir, do you have any questions?
No questions from my end either. Thank you so much for the topic and interesting study. Kind regards.
Thank
Thank
you.
you so much, sir. Thank you so much, ma'am. So with that, we have come towards the end of this technical session. I would like to sincerely thank all our authors for their excellent presentation and valuable contributions. I also extend my heartfelt gratitude to all the participants for being a part of this international conference. I hope today's session has been informative, engaging, and enriching for everyone. On behalf of the entire team, we thank you for your continued support during the 10th edition of WS4 2026, as well as throughout the previous 9 editions of the conference. We look forward to welcoming you again to the 11th edition in 2027. All presenters will receive their digital certificates via email within 2 working days. The conference publication will be available within 7 to 8 months. We kindly request your cooperation with the World S4 2026 team throughout the publication process. I would also like to express my sincere appreciation to our session chair, Dr. Gurdal Ertek and Dr. Priya Pise ma'am, for successfully chairing this technical session. I would like to request Dr. Gurdal Ertek sir to kindly share their review and remarks to the presenters.
Sorry, share what?
Remarks of the session.
Okay. Remarks on the session. Well, it's been a very interesting session. I mean, it's been there were two presentations on virtual reality, augmented reality, which was very interesting, and then there was sustainability aspect with Amazon forest and the other study as well. So it was overall, a bit of everything, but all of them interesting applications of computer science and especially for improving human life. So thank you so much for all the presenters, and thank you so much as well to the session coordinator, to you as well, and thanks to the session chair, Dr. Priya, right, Dr. Yeah. So that's all from my side. Thank you so much. All the best.
Thank you so much, sir. Now I would like to request Dr. Priya Pise ma'am to share their remarks on the session.
Yeah, hi. As rightly said by Professor, it was indeed a great time with all of you to listen to them, to what level of work they have done dedicatedly, and to listen to their ideas. It is indeed fascinating to all of us, where the world is moving for the betterment of the society. So I'm really happy to be a part of this conference today. So thank you for giving me a chance. And Samruddhi, you've been a wonderful one throughout the session.
Thank you so much, ma'am. With that, I would like to, on behalf of World S4 2026, Global Knowledge Research Foundation, and our partners, please accept this certificate as a token of our appreciation for your valuable support and contribution. This for Dr. Gurdal Ertek sir and
Thanks a bunch.
Thank you.
And thank you, Dr. Priya.
Same here, sir. Likewise.
Thank you once again for your valuable presence and participation. This concludes our session. Before we end, I kindly request everyone to switch on their cameras for a quick group snapshot of our virtual conference. Wait a minute.
1 minute, please.
Yeah, done. Thank you so much, everyone. Take care. And you may leave the meeting.
Thank you very much. Bye-bye.
Thank you.
Thank you.